So, concerning this course, which is Mat105, it is actually based on statistics for management, science and social sciences. So now, since we are dealing with statistics itself, so you have to understand these basics. These take notes. At first, when you are dealing with statistics, uh, statistics has two main types or two major types. So the two major types of statistics are the first one and the second one is the first one is what we call the descriptive statistics. Take note of that. The descriptive statistics, and the second one is what is the inferential statistics. The inferential. Now you see this descriptive statistics is also called deductive. Take note. Take note of this. This part of question two. And at the same time, this inferential statistics is also known as what? Inductive what? Inductive statistics. Now, since you understand the two major types of statistics, now you have to understand what you have under this. How can you describe a data? Now, take for instance, um, under this descriptive, you can only try to describe, when you're dealing with statistics, you have to collect a data, then what are you going to do with those data? It's either you describe them or you try to um, consider part of those data or without considering all the data you have actually collected. That is by taking samples. So the sample you picked, then you actually work on them, and then whatever results you get, you use it to give a generalization, a final conclusion for the whole population. Now, take for instance, whatever you be doing in these statistics for under Mat 105, you're only dealing with descriptive. So just forget about this inferential for now. And then this descriptive statistics simply implies how you can describe data. So you can describe a data in different form. And then I can easily split that into three. That will be the best thing. So the first one, if I decide to split it into the first one is you can either describe, it is descriptive statistics. So we can describe a data um, graphically. That's the first one. Graphical representation, that's what we call it. Graphical representation. And at the same time, the second part is we can describe a data diagrammatically. We call it uh, diagrammatic representation. Okay. And do you know the last one? The last one simply implies you measure those data. So you measure them. Now take note. I said we have graphical, we have diagrammatical representation, and we have um, the mode of measuring the data itself. So now for this graphical representation, that is where we have the histogram. If you want to draw an histogram, you will surely have to make use of a graph or a sketch. And at the same time, whatever you have under that graphical representation is the bar chart. Okay. And we have the frequency polygon too. Under it, you have the frequency polygon. And again, we also have the cumulative, please take note of this. We have the cumulative frequency curve. Take note. Cumulative what? Frequency curve. This cumulative frequency curve is also known as what? OGIV. This is part of MCQ question, multiple choice question. Please take note of them. So the main point, based on what I've explained so far, is actually the two main branches of what of statistics, or the two major types of statistics, which is descriptive, inferential, or deductive and inductive. Now, how can you describe the data? Is it that you describe the data graphically or diagrammatically, or you measure those data? So I've explained this. And at the same time, how do you represent a data diagrammatically? What do you have under this? That's where we actually have we have the pictogram. Yes, the pictogram. And then under this also, that's where we have the pie chart. The pie chart. Okay. And please take note, under this bar chart we have some components. We have component bar chart, we have the simple bar chart and all those stuff. So if you want to represent a data diagrammatically, is either you use a pictogram or you use a pie chart. I'm very sure you are all familiar with that. When you are when you are dealing with pie charts, that's where you actually have the cycle, and then you bring out any sector you want, the portion of the sector you want. It's either this sector represents engineering department, and then this represents the physics department, and so it depends on how you represent them in each sectors. So whatever I've done here, I'm just trying to show you a diagram, and I can easily uh, get my data from this particular diagram. So it depends on whatever I'm trying to define in this shape. And now the major work of this course, whether the calculations or anything, is actually based on their measures. So when you're dealing with measure, how do you measure data? So we have almost close to four of them, possibly four or five. So let's start. The first one is the measure of central tendency. Okay, so I'm trying to short it because of space, and that's the first one. We have the measure of central tendency. Measure of central tendency. Just mark. Okay, or measure of central tendency is also known as what? Okay, let me write it as MOCT. Measure of central tendency, or you call it what? Measure of location. Please take note. So the first thing you have under this measure is measure of central tendency or the measure of location. And at the same time, another measure is what? That's where we have the measure of dispersion. Measure of dispersion. That's mod. And this measure of dispersion is also known as what? Measure of variation. Please take note of that. And then when you understand this clearly, then we now move to what we call the measure of skewness, which is that is measure of skewness. We have measure of skewness. Skewness is spelled Skewness. Measure of skewness. And at the same time, the last one is what we call the measure of kurtosis. And kurtosis is spelled Kurtosis. Now, these are all the measures that we have to take note under this course. And then taking this one by one. So I'm still trying to draw the chart and everything. So the next thing for us to do from here now is to identify what we have under this measure of central tendency. Whatever you have under measure of central tendency is just the mean, the median, and the mode. Okay, that's all. And whatever you have under measure of dispersion, the first one is the range. Okay, then you take it one after the other. So here in this case, I will try to list this out. The first one we have under this thing here is examples of measure of central tendency is the mean. Okay, the mean. We have the median, and we have the what? The mode. These are the examples of measure of central tendency. So just take note of them. And at the same time, we have measure of dispersion. Now, this measure of dispersion, we have the first one, the first example of measure of dispersion or measure of variation is the range. Okay, we have the range. Then after this, that is where we have the mean deviation. Take note of that. So mean deviation, the best way to write this is mean absolute deviation. Mean absolute what? Deviation. Take note of that. And then after mean absolute deviation, we also have what we call the variance. The variance. After the variance, we have the standard deviation. the standard deviation. So then if you now understand clearly what standard deviation is, we can then move to what we call the fractals. We have the fractals, or fractals is also fractals. Fractal is also known as what? Quantiles. So I'll explain whatever we have under this case. Quantiles. So with this, I think this is sufficient enough for um, mean for measure of dispersion. And at the same time, we have a measure of skewness. This measure of skewness, you must understand what the definition is talking about. So measure of skewness is just a degree, a measure degree, is a degree of asymmetry. Just take note of that. Just short it that. Let's just short it that way. Measure of skewness is a degree of what? Of asymmetry. And you see this measure of skewness. This is a degree of thickness. It shows um, how you have this. Okay, let me explain it this way. You have measure of kurtosis. Measure of kurtosis is just trying to tell you that we have um, three different types, whereby the first one is the leptokurtic. The first one we have under measure of kurtosis is leptokurtic. Okay, and then we have the platykurtic. Sorry, we have the mesokurtic in this order, and the last one is what? Is the platykurtic. Now you see this leptokurtic, the graph or the way you have to, everything follows this. When you have an let's say you have an x-axis for each and every one of them. This is for platykurtic. Now let's sketch this graph for leptokurtic. It looks like this. It goes up in a very tiny form. It's taller. So this is how leptokurtic is. Whereby this is the average, this is the mean. Okay. And at the same time, mesokurtic looks like a normal distribution curve that is like this. This is a standard normal distribution curve, whereby this is the average, and this place is the mode. This is the thickness of that symmetry shape. So the symmetrical shape itself, this is the thickness from the definition. It measures the degree of thickness, how high it is. And then for platykurtic, it is more wider than the rest. This is for platykurtic. It looks like a plate. Whereby mesokurtic looks like a bell shape. Okay. First thing look like a bell shape, and then at the same time the mean is 0, the standard deviation is 1, and all those stuff. Now this is just whatever you have to. This is a summary of whatever I want to do, and then that's not the end. In addition to what I've explained so far based on this summary, this particular mean that we have here, for it to um, find any computations on mean, we have different types of them, whereby we have the arithmetic mean, that is AM. Okay, we have the geometric mean, is denoted as what? Capital GM. And at the same time, we have the harmonic mean. Harmonic mean is denoted as HM. And then finally, we have what we call the quadratic mean. And please take note of this. This quadratic mean is also known as, what? We call it root mean square. The root mean square. So if you see any question and you're asked to find the quadratic mean, that means you're trying to find the what? Root mean square. So quadratic mean is denoted as QM, or you will denote it as what? RMS. So take note of this. This is very, very important. And at the same time, what do you notice? From measure of central tendency, we have the mean median mode. For measure of dispersion, we have the range, the mean absolute deviation, the variance, the standard deviation, and the fractiles. So I noticed that this first one has been broken down, and at the same time, this first one can also be broken down too, whereby whatever range we can consider, we have different range, we have the percentile range and all those stuff. So now looking at this range, whatever we have to consider under this range, what do you have to notice about that? Whatever you have to take note in this is we have the interquartile range, which is the IQR, the interquartile range, take note of it. And we also have the what? Semi interquartile range. Let me put it that way. Semi interquartile range. That's SIQR. We denote this as SIQR. This semi interquartile range is also known as what? Quartile deviation. Please take note. So I'm trying to give you the summary of whatever I want to do, so that by the time we start solving questions, then you will know where the main source is coming from, where the main solution is coming from. You know the real source, where it's actually coming from. Now, this semi-interquartile range. Semi-interquartile range is also known as what? Quartile deviation. So then for this measure of dispersion, I can break down this range, and I can also break down this last one. What is called quantiles? Quantiles or fractals divides a distribution into equal parts. The only thing it does is that it only divides a distribution into equal parts, whether into half or into quartile or into, okay, the most common thing we actually do, the most common division we do is that you divide that distribution into half, which is median. Is that you divide it into four equal parts, which is the quartiles. Quartile, not quantiles. Okay, quantiles is the main source. Fractiles is the main source of the is that just like an heading. So we under it we have the median. We have after the median, then we have the quartiles. That is Quartiles. The difference is that one has R, but this is having N, quantiles. So then I mentioned two. It divides its distribution into half, which is the median. It divides a distribution into four equal parts, which is the quartiles. It also divides the distribution into um, 10 equal parts, and that 10 equal parts is what we call the deciles. Okay, and lastly, fractals divides its distribution into 100 equal parts, which is what? Percentiles. So I've listed four of them, right? Now, what I've just listed now, I have to just state it out. So by saying the first thing we have here is the quartiles, right? Do you agree with that? What are the types of fractals? We have the quartiles. Then the second one is what? We have the deciles. And the last one is what? We have the percentiles. So this is a summary of whatever I want to do. Now, you see these quartiles that we have here. These quartiles divides a distribution into four equal parts, right? That is where we actually have the lower quartile, we have the middle quartile, and we have the upper quartile. So you can't have Q4. Never. If you have Q4, then that means you are not dividing anything. Is it that you have, when for you to form a fraction, if you have this box now, and I want to divide this box into four equal parts, that is 1, 2, 3. So what type of fraction can you fill here? I can fill this. If I fill this up, I can say this is 1/4, right? What's another possibilities? I can also fill this place. That is what? That is the fraction is 2/4. And I can decide to fill another one. That's 3/4. But by the time I fill, you see, all these things are still showing that yes, I divide that distribution into um some parts, okay, whether the lower, the middle, or the upper is 3. And then if I decide to shade everything and I call it 4/4, am I still dividing? No, this is not showing that I'm actually dividing anything. This gives me a whole number. So the highest you could have is just Q1, Q2, Q3 for quartiles. So for quartiles, we have the Q1, we have the Q2, and we have the what? The Q3. So you can't have Q4. whereby this Q1 is called the lower quartiles, the lower quartile, okay? The lower quartile. And this one here is called the middle quartile, the middle quartile. And this last one is called the upper quartiles, okay? So please take note, all these things have their formulas, okay? This is just whatever, I'm trying to summarize everything you have to do on Mat105, and this is what you have to touch, everything, okay? And then mind you, this mean, we also have weighted mean, so but let's just consider this at first, okay? Next is the deciles. Similarly with what I've explained so far, deciles divides a distribution into 10 equal parts, right? So since deciles divides a distribution into 10 equal parts, so what are the possibilities you could have? That is either I have D1, D2, just like what I've explained here. If I have, let's say I have a rectangle box in this case, and I want to divide this into 10 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I shade this, I could rather have, I can have 1 over 10. So I can form another fraction from here, which is 2 over 10. You understand that? And I can form just like that. I can have 3 over 10. I can have 4 over 10 up to 9 over 10. But I can't have 10 over 10. This does not show division. Okay? So that means I can only have the lower part, which is this is the lower and this is the upper. Okay? Just like this. This is the Q1 and this Q2. Q1 is 1 over 4. Q3 is 3 over 4. Yeah, D1 is 1 over 10 and D9 is what? So that means deciles, you can only have D1, D2, D3, up to what? D9. So this is the lower decile and this is the upper decile. So what is the middle decile? That's D5. Take note of that. And then the next one is the percentiles. The same explanation will be stated for percentile, which is if you have 10 different um, 10 different sections in a box, 100 different sections in a box, and they are trying to express their fractions, then you can only have percentile 1, which is the lower, but not this is not the lower, it is it's now wide, it's wide enough. So since it's 1 to 100, so we either pick it in tens, okay? Here we only have um 1 to 4 just unit, you can just pick a digit. So here in this case we have just 10, but when you have 100, it is clearly seen that P10 is just the lower and P90 is the upper. This will be the best way to explain that. So most especially whenever you see questions, you will be asked to find P1, or else you might end up not seeing the position on your table. You might not understand what I'm trying to say. So percentiles simply implies um, P10. We have P10, okay? And most especially, they will not ask you to find P15. What I've noticed so far is they will actually ask you to find this in tens or maybe 15. They can ask P15, but not P13. You have P10, you can have P30, you can have P50, okay? You can have it up to P90. This is the highest you could have, okay? Whereby this is the lower and this is the upper. If you're trying to find the percentile range, I can just decide to find P90 minus P10. So percentile division will now be P90 minus P10 over 2, something like that. So this is for percentile. Do you understand that? And then I think um, with this explanation, then we can go ahead and solve any questions. So, but at first, we have to pick it from measure of central tendency, measure of dispersion, then in that stage, okay, this is how it's going to be. If I take this mean, I have to explain everything I have there. Then for arithmetic mean, I'll give you the formula. Geometric mean, I'll give you the formula with example. Harmonic mean, the same thing, and quadratic mean with examples. Then we are done with that. Next one is to explain the median. I will do that. Mode, the same thing. Then after that, then I'll verify that I've actually finished measure of center tendency. And then the next stage is to go to the measure of dispersion. Measure of dispersion is where we have the range, the mean absolute deviation, the variance, the standard deviation, and the fractals. So for this range now, that is where we have the interquartile range, or we have the semi-interquartile range. Semi-interquartile range is also known as quartile deviation. Do you understand that? So I'll give you the formula for IQR and the formula for SIQR. So we just take it stage by stage. And at the same time, give you the formula for mean absolute deviation with examples, variance formula with examples, and I also give you standard deviation, likewise with examples. Then move straight to fractals. Fractals also, I'll do the same thing. I'll give you the formula for quartiles itself, and I'll give you each of these formulas. What Q1 is, Q2 and Q3 is. Then like that, and deciles and then percentiles. And then move straight to measure of skewness and measure of what cortices. And I think with that, then I believe if I'm able to finish all these things, then that's you are good to go with Mat105. So the only thing we just have left after all this sketching stuff is, do you know the final thing? The final thing is where we have the correlation and regression. That's all. That's the final topic that we have under this course. The correlation and what? And then and regression. So this is just a summarized explanation I could give you on Mat 105. So thank you. See you in the next class.